A standard normal random variable has PDF. Since it is a PDF, we can find the probability that our random variable is in some interval by evaluating an integral. There's just one problem. We can't actually evaluate this integral. Specifically, there's no elementary function whose derivative is this PDF. So how can we use the normal distribution? To do that, we can approximate the value of the integral numerically. So remember that e to the x is one of those functions that have a nice power series expansion that's going to be convergent for all values of x. So using our power series expansion, we can express our PDF as So let's find the probability that x is less than or equal to 0.5. So that's our integral. Since we're going to be using an infinite series, let's avoid having an infinite interval as well. Fortunately, we can split our integral at 0 because we know the integral from minus infinity to 0 is 0.5. And so that means we can focus on this second integral. And so we'll substitute in our power series expansion, and we'll remove that constant factor. Since the series is absolutely convergent everywhere, we can interchange the integration and summation. This allows us to do termwise integration, and so we get While this is an infinite series, note that it's an alternating series. And in general, the error in using the sum of the first k terms of an alternating series is no more than the absolute value of the k plus first term. There are some additional requirements which we can talk about in another course. So we'll find the first few terms of this series. If n equals 0, we have if n equals 1, we have if n equals 2, we have if n equals 3, we have and again, since this is an alternating series, if we don't include this term, our error will be at most the absolute value of this term, and that would give us a value that's correct to 4 decimal places. So let's stop at this point, which gives us the approximate value of the integral. We can substitute that back into our formula for the probability that x is less than or equal to 0.5, and there we have it. Consequently, if civilization collapses and the internet and all electronic devices are destroyed by a massive EMP burst, and you need to find the probability that the height of a 3-year-old tree is between 27 and 38 inches without a calculator, well, you could. But fortunately, somebody else has done all this work already, and so we have tables of the standard normal distribution function. We'll take a look at those next.